Right, in this lesson, we're going to talk about parallel lines in the coordinate plane. So we're going to be writing equations for parallel lines. So it's going to be really important that we understand the connection between the equations of lines that are parallel and their slopes. So parallel lines, since they are moving in the same direction at the same rate, they never cross. The movement of a line is the slope. So parallel lines have the same slope. So we're going to look for two lines. If they have the same slope, then they're going to be parallel as long as they have different y-intercepts. So we're going to use that slope formula that we talked about in the previous one and in the previous lesson. And that's going to be the change of y over change of x. So y2 minus y1 over x2 minus x1. And that's based on two ordered pairs. And we're also going to be using slope-intercept form of a line, which is y equals mx plus b. So in example 1, here we have 3 sets of ordered pairs, and we're given the name of a line that passes through them. So line P passes through points 0, negative 3, and 1, negative 2. Line Q passes through points 5, 4, and negative 4, negative 4. And line R passes through negative 6, negative 1, and 3, 7. So each of these could have this little line notation over it to make it more clear. So we're going to find the slopes of each of these different lines to figure out which two of these three are parallel. So starting with point P, if I want to find the slope, I'm going to first label x1, y1 for the first ordered pair, x2, y2 for the second. And then I'm going to plug those points or those numbers into my slope formula. So for y2, I plug in negative 1, and then that's going to be minus negative 3 for y1. So y2 minus y1. On the bottom, I'm going to do x2 minus x1. So 1 minus 0. I'm going to go through and subtract and simplify. So negative 2 minus negative 3 is the same as negative 2 plus 3. That's going to be positive 1. On the bottom, I have 1 minus 0, which is 1. So once I have that, I'm going to simplify. And 1 divided by 1 is 1. So the slope of line P is 1. For our next line, let's label x1, y1, x2, y2, and plug those into our slope formula. So for the top, that's y2 minus y1, negative 4 minus 4. And for x2 minus x1, that is negative 4 minus 5. So as I go through and simplify, negative 4 minus 4 is negative 8. On the bottom, negative 4 minus 5 is negative 9. So to simplify this, I'm going to first look at the signs. Since they are both negative, that is going to be a negative divided by a negative, which will make a positive slope. And 8 over 9 does not reduce. So the slope of line Q is 8/9. Since 8/9 is not the same as 1, line P is not parallel to line Q. They do not have the same slope. So now let's find the slope of our last line, which is line R. So for this slope formula, I take my second y value and subtract the first y value. So 7 minus negative 1. And then on the bottom, I do x2 minus x1. So that'll be 3 minus negative 6. So on the top, 7 minus negative 1 is the same thing as 7 plus 1. So that'll be 8. On the bottom, 3 minus negative 6 is the same as 3 plus 6, which will be 9. So the slope of line R is going to be 8/9. So looking at the slopes of these three lines, I notice that both line Q and line R have a slope of 8/9. So line Q and line R will be parallel because they have the same slope. So in geometry notation, we like to have ways to shorten things. So if I want to say that line Q and line R are parallel, I'm going to use the symbol for parallel. So I say line Q and line R, and then in between them, the symbol for parallel are two vertical lines, much like the two L's in the name. So parallel has those two vertical lines, and they're a little bit taller than letters. So there is a key on your keyboard that can do a vertical line like that. That's with your backslash, I believe. So you would just do two of those to say that something is parallel. So whenever we're looking at parallel lines, we're always looking at having the same slope. So on example 2, this is writing the equation of a line from a point and the slope. So here we are given that the slope of this line is -2, and we're given a point 4, 9. So if we think about slope-intercept form, y equals mx plus b, what I'm going to do is I'm going to plug in the slope, but then I'm also going to plug in the values of x and y based on that ordered pair. And the only information that I don't have at this point is b. That's what I'm going to have to solve for. So if I plug in the information that I have, the y value that I was given is 9. The slope that I was given is -2. And the x value I was given is 4. So I leave the variable b because that's what I'm solving for. So the first thing I need to do is to simplify this multiplication. -2 times 4 is -8. I'm going to bring down everything I haven't used. And then I'm going to work towards solving for b. So to move this -8 to the other side, I need to change its sign and do, +8. So I'm going to add 8 to both sides. 9 plus 8 is 17. So that tells me that the y-intercept of this is going to be 17. So now that I have enough information to write it in slope-intercept form, I have both the slope and the y-intercept. For my y-intercept, I'm going to plug in 17. And for my slope, I'm still plugging in -2. So when you write the equation, it should always be in y equals form. Then I'm going to plug in my slope of -2. And then my y-intercept of +17. So the equation of this line would be y equals -2x plus 17. So there is a check your progress problem that you'll do on the Google form. So the next thing we're going to do is we are going to write the equation of a line through a given point that is parallel to a given line. So when we are talking about parallel lines, the main point here is that parallel lines have the same slope. So from the line that we were given, we really only need to figure out what the slope of that line is. So in this equation, y equals 2/5 x plus 3. The only information that I need from this line is the slope. So the slope is always the number that's found in front of the x when it's in this y equals form. So the slope of this line is 2/5. So once I have the slope of the parallel line, I'm going to use that as m. And then I'm also going to use this point that was given. And these are the two things that I'm going to plug in. So for slope-intercept form, y equals mx plus b, I'm not using this same b value because then I would just have the same line that I started with. That wasn't the question. It wanted a parallel line that goes through this other point. So I'm going to plug in a y value, an x value, and the slope and find a new y-intercept. So the y value of the point that was given is 0. The slope of the line that was given was 2/5, so I'm going to use that same slope to be parallel to it. And the x value that I was given was -5. So I start with simplifying and multiplying the slope by the x value. So 2/5 times -5 is going to give me -2. And then to get the b by itself, I'm going to add 2 to each side. So 0 plus 2 is 2. So that's going to be my b value. So I'm going to use this. I'm going to use my slope to write my equation of the line. So the equation of the parallel line will be y equals 2/5 x, and then my y-intercept was 2, so 2/5 x plus 2. So notice that this line that we just wrote has the same slope as our original line, but it has a different y-intercept. So we just ignore the y-intercept that was given us in the beginning, and we're writing a new line that is parallel to that original. So the one right below that is a check your progress problem, and it's going to follow those same steps. So find the slope of the line that was given, and then use the point to find the new y-intercept. So not all lines are given to us in slope-intercept form in the beginning. So I can tell that this line is not written in slope-intercept form because the y is not by itself. So before I can figure out what the slope of that original line is, I'm going to have to change that into slope-intercept form. And the way that I do that is by isolating that variable y. So I need to move everything away from it. So the first thing I'm going to do is I need to move this positive 2x that's up front. So to move that to the other side, I'm going to do the opposite to cancel it out on this side. I'm going to subtract 2x, and that'll cancel it out. And anything I do on one side, I have to do on the other. So where this gets tricky is that 7 and negative 2x are not like terms. They don't combine. So I just write those as two separate terms now. So this is a positive 7 and a negative 2x. So I like to put my x value in front. So that's going to be negative 2x. And then I'm going to put the plus 7 at the end. So they don't combine. They just get written together on that same side of the equation. On the other side, I still have negative 3y. And my goal is to get that y completely by itself. And it's still not completely by itself. So now I need to divide by negative 3. So when I divide by negative 3, I do that on both sides. And when I do that on the right side, both terms are getting divided by that negative 3. So if I think about this broken down as each term being over negative 3, so that's negative 2 over negative 3x, and then plus 7 over negative 3. So if we simplify this, let's check our signs and see if anything will reduce. So 2 over, or negative 2 over negative 3, those are both negative, so that's going to become a positive 2/3 x. And then I have a positive 7 over a negative 3, so that's going to become a negative 7/3. This is still the original line, though. And from that original line, the only thing I need is the slope. So I don't care anything about this y-intercept of that original line. I only care about the slope. So if the slope of the original line is 2/3, in order to be parallel to that, I'm also going to use that same slope of 2/3. So now that I have the slope, I'm going to use this slope, 2/3, as m. And then I'm going to use this ordered pair that I was given as my x and my y. So I'm going to plug that into my new slope-intercept form in order to find my new y-intercept. So for each of these, I'm going to plug in the values that I know. So the y value that I know is 1. The slope that I need to use to be parallel is going to be 2/3. And the x value is going to be negative 3. So the only thing that I don't know that I'm trying to find is the new y-intercept. So first thing is going to be to multiply that slope by the x value that we wanted. So 2/3 times negative 3 is negative 2. So negative 2 plus b equals 1. And then to get the b by itself, I'm going to add 2 to both sides. 1 plus 2 is 3. So 3 equals b. M is 2/3. So the equation of this line, if I put it into slope-intercept form, My slope is 2/3, so I put that in front of x. My y-intercept is positive 3, so I put a plus 3 at the end. So the equation of that line is y equals 2/3 x plus 3. So there's also a check your progress problem based off of that method.